All right. So, polynomial equality. All we have to do with these ones is we're told the left-hand side is equal to the right-hand side. That means they're the same function on both sides. Now, if these polynomials are equal, what it means is the x squared term here is equal to the x squared term here. All right, so what that means is x squared is equal to a times x squared. And so from this we can discover those unknowns. The value of a has to be, what's the coefficient here? Positive 1. So we have a has to be positive 1. All right, if we look at the next one, we have positive bx is equal to negative 7x. We're equating the x terms. If the polynomial is equal, the x squared terms equal, the x terms are equal. So what we would have is we would have bx is equal to minus 7x. All right, the x terms are equal. And what you can think about doing is where we want what's the value of b that makes this true? Well, b has to be minus 7. All right, we can see that they are equal. And so the value of c then, c is the constant term, the one that doesn't have an x, c is root 3. Okay, so you're not expected to show any working out for a question like this. It's just a matter of going a is 1, b is minus 7, c is root 3. In the next one, there might be a little bit of processing. All right, again, we have a quadratic on the left-hand side and a quadratic on the right-hand side. So all I'm going to do is equate the coefficients. All right, here on the left-hand side, we have 8, lots of x squared, and on the right-hand side, we have 4a. So we have 8 equals 4a. The coefficients of the x squared term are equal. We'll divide both sides by 4, and we'll have the a value is 2. A has to be 2 in order to satisfy the equality. All right, we've got in brackets b take 2 on the right-hand side, and on the left-hand side, the coefficient of the x term is minus 1. So we have minus 1 is equal to, and on the right-hand side, the coefficient of the x term, b take 2. All right, we're going to plus 2 to both sides to get b by itself. Minus 1 plus 2 is positive 1. So we determine the value of b. And then we have this whole thing here is the constant term because there's no x belonging to it. So we have c take away 9 is equal to 5. And we'll plus 9 to both sides to get c is 14. All right. Now, drop out example 3. We have 2x squared, take 26x plus 72. Equals ax plus b times x take 9. Okay. Now, when we're confronted with something like this, we can't directly equate unless you've got some really good insight. What we have to do first is completely expand that. Over here, we have 2 linear factors, and we know that x to the 1 times x to the 1 is going to give us an x squared. On the left-hand side, we do have a quadratic, so they are equal. Let's expand what's on the right-hand side. So we're doing FOIL, and I want to reveal another number of ways that we can think about FOIL, right? What we have is we have ax times x, that's ax squared. And then I'm going to do minus ax times minus 9. So that's going to be take away 9 lots of ax. So basically what I'm doing, rather than thinking of FOIL as a maths teacher, I'm going, this term needs to multiply both of these, and then this term also needs to multiply both of these. So then I do, okay, now b times x, that's going to be plus bx, and b times minus 9, that's going to be minus 9b. Okay. So what we have here, we have ax squared, we have take away 9ax and plus bx and take away 9b. That's what's on the right hand side. Now, from here, we can actually solve the values of A and B. All right, we can see that A has to equal 2. All right, the coefficient of x squared is the same. And we can also see that minus 9b has to equal positive 72. So we can solve for b there. However, I do want to simplify this because this is a skill that will pop up. Here, we should look at that and go x is common to both of them. So I'm going to factorize x out the front. What we would have, I've factorized x, and in brackets we would have minus 9a plus b. Now I'm going to write that in a few different ways, okay, just to familiarize you with what's going on. All right. Firstly, we could write it as b take away 9a. Okay. And then generally speaking, whenever we're writing a quadratic out, we always put the number first and then the x. So we would have ax squared plus b take 9a times x, and then take away 9b. Now, all of what I've done there is accessible in this step. You can see, if you're looking at this, we've got b, take away 9 lots of a, and then the x, okay? X is common to both. So you can go from there to there absolutely fine. If you want a process to know how to do it, what do? You factorize x, and then we express the number at the front. Okay, so now let's equate the coefficients. We know a equals 2. All right. We also know we have two ways now that we can access b, because we know from the x term that b take away 9a is equal to minus 26. All right, b take away 9a is minus 26. And we also have minus 9b is equal to positive 72. Okay, so we've solved A is 2. We can use either of these to solve B. Definitely this one will be easier, right? All we have to do is divide both sides by minus 9. 72 on minus 9 is negative 8. 9 to 72. Okay, so we can get B from there. However, I want to show you how we can also derive B from this equation. We know that the value of A is 2. So I'm going to put the value of A into this equation. So we would have B take away 9 times 2 equals minus 26. So I would have B take away 18 is minus 26. And then we would plus 18 to both sides, and negative 26 plus 18 is minus 8. So there's a bit more work involved there, but what this demonstrates is that if you've established equality here, the relationship maintains in the middle term. Okay? So, when you're doing this kind of question, you just have to find the values of A and B. It's perfectly acceptable just to do that and that. You don't need to perform this process, but there will be some long ones where we do need to. So, let's have a look at our last example. These are lots of fun, very methodical. We have 2x to the 3, take 9x. Now I might take the whole board actually. Does anyone need to still write this down? No, filled it anyway. So we have 2x to the 3, which means we've got a cubic. Take 9x squared plus 7x plus 6, and that's equal to 2x take 1. So a linear factor multiplied by, plus 1, thank you, multiplied by a quadratic, ax squared plus bx plus c. All right, 2x3, take 9x squared plus 7x plus 6, 2x plus 1, ax squared plus b plus c. Good. Okay, so we can't equate yet. All right, maybe you can see the a value, I can see it. Maybe you can see the c value, I can see it. But if we can't see it, we're going to have to expand. All right. So what we have to do, again, we have here, you haven't done this before probably, we have a linear times a quadratic. And so the best way to think about it, it's not FOIL anymore because we don't have two terms there. we're going to have to go this term multiplied by every single term in that bracket. So firstly, we're going to get 2x times ax squared. That's going to be 2a x to the power of 3. All right, when we have x times x squared, that gives us x to the power of 3, and 2 times a is 2a. Okay, so that's multiplied the first term. Then I'm going to multiply the second term. That's going to be 2b x squared, because we have x times x. And then we have 2x times c, so 2cx. All right. Now this strategy that I'm going to teach you here is going to be a staggered approach. I think this is the best way to do it. So we've multiplied this term by everyone in there. Now we need to multiply the second term by every term in the second bracket. Okay, so first I'm going to do plus 1 times ax squared. Now historically, if you were doing this, you would have written it up here. You would have gone plus ax squared. But this staggered approach, okay, it's plus ax squared, it's x squared, which means we're going to write it underneath this term. All right, we've got 1 times ax squared, it's x squared, so I'm going to write it underneath the x squared term. Then I have 1 times bx, so that's going to be plus bx, and I'm going to write it underneath the x term. And then the last one is 1 times c, and that's going to go here. Now the reason we do this, the beauty of this staggered approach, is that it makes collecting like terms very easy. If you've got this really long-winded expression, it's quite difficult to see what correlates, whereas here they're written directly underneath one another. So if we collect like terms, there's nothing to collect for this one. We just have 2ax to the 3. And then we look at the next one. We'll always do a plus. I'm going to open brackets. And all we do is we go, here we've got 2 lots of b plus a. And that's multiplied by x squared. Okay, they are the x squared term. 2 lots of b plus a going in the brackets there, and they're multiplied by the x squared term. In the next one, we're going to open up the brackets. We have 2 lots of c plus b, and that's multiplied by x. And then we have the plus c hanging out all by itself. Okay, so we have fully expanded this polynomial. And now all we need to do is equate. We're equating it with this polynomial. In fact, what I'm going to do is write this polynomial immediately underneath it so we can see the overlap. 2x to the 3, we have take 9x squared, and then we have plus 7x, and then we have plus 6. Okay, so like that, we can really see very clearly which parts correspond with which. We can see C straight away. C is positive 6. We can see A straight away. A is positive 1, not 2. There's already a 2 there. 2 times A equals 2. So A has to equal 1. 2 times 1 equals 2. All right. Then we have to use either this equation. All right, so we've got 2 equations there. We have 2b plus a equals minus 9. Or 2c plus b equals positive 7. We've got 2 equations there, and we need to use either of them to get the value of b. Notice how b is in both of them. They're both going to reveal the same value of b. In our example, we're going to process both. When you're doing it in the textbook, you can just process one. So if we have 2b plus a, we know a is positive 1. So first we'll sub a in. Then we'll take 1 from both sides. And then we'll divide both sides by 2. All right. If we're solving this equation, we know that c is positive 6. So we have 2 times 6 plus b is 7. We have 12 plus b is 7. And then we subtract 12 from both sides. We get the same value of b. Okay, so the exercise will start like the first example, and then they'll get more complex with the expansion. It's my recommendation when we're doing this expansion, we do the staggered approach. Whenever you're moving from here to the brackets, you must carry the whole coefficient. So what I mean by that is if this one's negative, okay, you have that negative there with the A. If both of them are negative, all right, these are both negative in the bracket, but always keep that as a positive next to the brackets, always positive, and you just carry the negatives inside the brackets. Okay, and then that makes the equating absolutely fine. So that's where we'll dedicate our efforts today, 4A.2. Let's get into it.